All right, you guys, welcome back to Phase Changes. We're in lesson 3.3 today, modeling attraction. We're going to go ahead and hop right into the warm up. So, in this lesson today, we'll be doing part 1 through 4. So, in your warm up activity, we're going to look at that modeling attractions marble activity that you did in one of the last net lessons. So, you're going to just do you think it would be harder to get the strong magnets to change phase or change what phase they're in? Because right now, as a magnet, and they're not moving or barely moving, they're in a solid state of matter. And do you think that it would be harder to get those to change? And then explain. And you have a second question there about energy transfer into the two solids. So make sure you answer that question as well. Pause the video here so that you can answer your warm up questions. So we're going to move on to activity 2, where you're going to be explaining the attraction between the molecules. So let's review your predictions. If you want to pause the video here and discuss with your partner, what do you think will happen when the two containers of magnets are shaken? In an earlier lesson, you actually used these marbles to model how molecules behave when you transfer energy to them. In this video you're about to watch, you'll see the model just like the one you used, and a second model where the marbles are made of much stronger magnets than the ones that you had. So here's that video. So in that video, what did you observe about the model? What did this video show you about molecular attraction and phase changes? So hopefully you saw a difference between the stronger magnets and the weaker magnets. When we saw more energy was transferred into the stronger magnets, they needed to have more of that energy in order to make their freedom of movement increase. So this model actually shows the idea that more energy must be transferred to a substance that has a higher molecular attraction in order to make it change its phase. The model also shows the idea that the substance with the higher molecular attraction will condense or freeze more easily than one that has a different type of attraction. So let's compare this model to some things that you use every day. Butter and oil are in different phases at room temperature. Butter's a solid, oil is a liquid. So which marbles in the model would represent butter and why? Talk with your partner and pause here to see if you guys can come up with an answer to that question. So hey, welcome back. The stronger magnets would actually represent the butter because they need more energy to increase their freedom of movement. The butter needs more energy to be in the liquid phase than the oil. So let's look at this key concept. At this point, you should know this key concept and the next one. Whether or not a phase change occurs is determined by the interaction between the kinetic energy or energy of movement of the molecules and the attraction pulling the molecules together. We also know that the molecular attraction, let's go back to that slide. The molecular attraction of a substance never changes. So how can you connect this key concept to the video? If the molecular attraction of a substance never changes, how do you connect that to the video? Well, maybe this key concept was shown in the model because each type of magnet kept the same amount of attraction the entire time. So we have a letter to read to us chemists. I was impressed with your well-supported arguments and whether the lake evaporated or froze. I would also appreciate your help in investigating the user question on the forum about why the liquid methane lake didn't change phase earlier. Please discuss and use the modeling tool to illustrate your ideas, then send us a screenshot along with a brief explanation. Your explanations will help us answer that forum user's question. So today you're going to use the write and share, and in your binder you have write and share pages, and there's one for explaining the attraction with liquid oxygen, and one for the magnetic marbles video, and one for the sim. So you need to get in a group of 3. And each member is going to evaluate a different piece of evidence. So if you look at part 2 of your lesson, you can actually see down here at the bottom that you are going to click on each card. So it just kind of gives you a scenario and saying that we're looking at why the liquid methane didn't change phase before 2007. So then you'll have the student that will look at this one that's evaluating the evidence from the sim. Then you'll have one person looking at the magnetic marbles video, and then you'll have one person evaluating the phase change from liquid oxygen. Now remember that sharing your article and what you have learned from your article for with each other is very important because you want to make sure that each student is getting the information that you guys need to understand from each piece. So after you've answered your writing prompt and you have used the vocabulary words that are on the screen, have everyone in your group take a chance, take a turn, and get a chance to give their evidence and share their responses. So while one reads, the other should listen. And afterwards, you guys can ask each other questions. So let's read an example of a description of what the strong magnets show about attraction. This explanation uses the vocabulary words each group member will use. So this video shows that even when a lot of energy is transferred in, the freedom of the molecules movement may not change. In this case, the molecules do not have enough kinetic energy to overcome the attraction that is holding them together. So each member will grab one of those prompts and they will use the evidence that they have to respond to the questions. So you're going to want to pause the video here so you guys can go ahead and complete this activity in part 2. Now, as a group, you should be discussing this question. Why do you think the liquid methane didn't change phase before 2007? So we're going to look at this key concept because at this point, you should understand this key concept and you should have answered this question. So if you need to pause, go ahead and pause and answer this question. So your key concept is that a phase change occurs when the kinetic energy or energy of movement increases enough to overcome the attraction between the molecules. Now remember, it's the same attraction, it's just that they're moving fast enough now that they can overcome that attraction. So key concept number 12, a phase change occurs when the kinetic energy decreases enough that the attraction between molecules pulls them together. So when you decrease that amount of energy, then that pull of attraction, it doesn't get stronger. It's just easier for it to be attracted to each other because it doesn't have the particles moving around as fast. So then the last concept we're going to look at is different substances can have either weak or strong molecular attraction. So if you'll pause the video here, if you haven't finished activity 2, we're going to move on to activity 3. So in activity 3, we're going to be modeling attraction. So let's hop in there. Next, you're going to use the modeling tool to represent what happens on the Lake Titan. Let's start by reviewing the timeline of Titan's summer. So if we look at the summer, we know that it started in 2002. We didn't see the lake photo happen, and it's still liquid in 2007, but we didn't see the lake in 2009. So we have had a few years since summer started. So you are going to hop in and create a model showing why the lake evaporated between 2002 and 2009. Then you'll create models showing why it didn't happen before 2007. So first thing we're going to do is drag the substance boxes over. The 2002 box should be lower in energy because we know that it was in liquid form, while the other one should be higher where we are showing what happened in 2009. So we can edit the description of the substance right here. You can change it to a liquid and set the attraction levels for 2002 as low because it was a lower energy level. Now we're going to edit the description for 2009's lake and choose gas and put the attraction level as low because remember, the attraction doesn't change. You should complete the rest of the selections in your model as you go. And there are two kinds of energy arrows that you will need to know about. We have the actual change in energy and then the change needed to change the phase. So the solid arrow is the actual change, where the dotted one is how much energy is needed to make that change. So you're going to need to consider how much energy that needed to go into the substance in order to make the change happen. You can move the solid line arrowhead to the horizontal line of 2009 by pulling it up. And to show the energy was transferred into the lake, label it A with the hexagon from the side over here. For this model, I need to show that the lake evaporated. For evaporation to occur, I need to show that the energy needed for the phase change models needs to overcome that attraction. So you're going to label that so it will demonstrate that, because we know the actual energy that was enough to actually cause that phase change. So we need to have the arrow be the same size or shorter than the actual change. And we're going to label that with Z. So hop into your lesson right now, pause this video, and answer those questions. Okay, why do you think that the lake didn't evaporate before 2007? So consider how that interaction between the attraction and the kinetic energy affected methane. So the last thing that we're going to do in this lesson today is part 4, which is the homework. For this activity, you're going to write a message to Dr. Flores explaining why the methane changed after 2007. You're going to read and annotate the article that you see on part 4 in screen 1, and then in screen 2, you will read the actual article and annotate it. So you have a question in the first one that you're going to write back to Dr. Flores, and then you will read the article in the second card. So that's the end of the lesson. Please make sure you look over your mastery checks before you ask the teacher to come over and check out your lesson and take your mastery checks. So look over those key concepts just to make sure you get it.